Hey there, and welcome to today's Explainer. I'm so glad you're joining us. Look, today I'm going to step into the shoes of your personal career advisor, and we're going to map out an incredibly exciting, totally future-proof academic path for you. If you think you know what chemical engineering is all about, well, get ready to have that perspective completely flipped on its head. We aren't just flipping through textbooks today. No, we're looking at a literal blueprint for global innovation. So here's a question for you. Want to actually help solve the climate crisis and build a highly lucrative career at the exact same time? For decades, people heard chemical engineering and immediately just thought oil and gas, right? But today, that's completely changed. This discipline is at the absolute vanguard of a sustainable, self-sustaining energy future. It's basically the ultimate toolkit to tackle the world's biggest environmental challenges while setting yourself up for a really rewarding professional life. Okay, here's our personalized roadmap for today. We're going to cover the green tech revolution, what's actually inside your B.Tech syllabus, essential skills for success, public versus private sectors, salary scales and growth, and finally, your global career pathway. Let's dive right in. All right, first up, the green tech revolution. We are talking about the massive shift from fossil fuels to a sustainable future. We are literally in the middle of a massive global paradigm shift. The old world of chemical engineering, it was very much a linear take, make, dispose model, completely tied to traditional fossil fuels. But the new world we're stepping into is all about the circular economy. Today's engineers are out there pioneering carbon-negative biofuels made entirely from agricultural waste. These are innovations that are already slashing emissions by 40% while actually powering rural communities. So you're not just refining crude oil anymore. You're designing green hydrogen systems. You're creating biodegradable polymers. It's a whole new ballgame. Now, you might be asking, why does this matter to me right now? Well, here's the crazy part. By 2030, the green tech sector alone is projected to need 1.5 million skilled professionals. That is a massive number. It's a booming industry, and it desperately needs forward-thinking engineers who know exactly how to design eco-friendly solutions and cut down on industrial waste. There's a huge seat at the table waiting for you. Moving on to part 2. Inside your B.Tech syllabus. Let's look at your 4-year academic roadmap. So, how do you actually become one of those highly sought-after professionals? Let's bring that grand, global vision down to your day-to-day college reality. Now, your first year is mostly foundational sciences, but by your second year, you're diving deep into fluid mechanics and thermodynamics, really understanding how energy and materials move. Then, in your third year, things definitely heat up with chemical reaction engineering and mass transfer. And by your fourth year, you're actually designing process equipment and figuring out how to mitigate industrial hazards. You are literally learning how to take a tiny molecular discovery made in a lab and scale it up into a massive, safe, and highly profitable manufacturing plant. And let me tell you, this rigorous academic framework, especially at top-tier institutions, is purposefully designed. Leading institutes give you the exact laboratory environments, funded research centers, and state-of-the-art simulation software you need to actually master these complex processes. You aren't just sitting there memorizing old theories. You are getting your hands dirty running computer-aided molecular designs and complex process flow simulations. Okay, part 3, essential skills for success. This is what hiring managers are actually looking for. All right, putting my career advisor hat firmly back on for a second. Getting the degree is honestly only half the battle. Your degree proves you have technical capability, sure, but actually landing the job, that often comes down to very specific practical skills. Hiring managers want to see proficiency in project management tools, things like PERT and CPM. They want rigorous hazard identification and life cycle assessments to make absolutely sure your processes are safe and sustainable. And please, never ever underestimate interpersonal communication. Engineering at this scale is a massive team effort. If you can't communicate complex data clearly to your team, well, you're just not going to thrive in a modern plant. I love sharing this. Here's a brilliant piece of real talk from a peer over on a Reddit engineering forum. Out there in the real industry, the whole world revolves around acronyms and strict safety protocols. So getting familiar early on with things like Six Sigma methodologies, piping and instrumentation diagrams, or P&IDs, and throughput modeling, that gives you a massive, massive competitive edge when you walk into that very first technical interview. Which brings us to part 4, public v. private sectors. It's time to choose your industry entry point. A B.Tech in chemical engineering is incredibly versatile, and it basically gives you two distinct avenues for placement. On one hand, you've got public sector undertakings, or PSUs. Think companies like ONGC and IOCL. These offer highly stable careers with fantastic government benefits, and you usually get in via the GATE exam. But on the other hand, you have the private sector, giants like Reliance and Tata. This side of the fence offers rapid growth, agile innovation in green tech and specialty chemicals, and some really fantastic opportunities for global mobility. Now for everybody's favorite topic, Part 5, Salary Scales and Growth. Let's talk about the financial rewards of all your hard work. Chemical engineering is pretty universally recognized as one of the highest-paying engineering disciplines out there. If we look at realistic averages in India, an entry-level chemical engineer can expect to make around 4.8 lakhs per annum. But once you move into a senior process engineer role, that jumps to about 6.4 lakhs. Or, hey, if you lean more towards academia and research, a professor role averages around 10 lakhs per annum. But keep in mind, those are just the averages. If you enter top-tier PSUs or you're graduating from one of the premier institutes, the financial rewards completely skyrocket. We're talking about exceptional starting packages hitting 16 lakhs per annum straight out of college. And with a bit of experience, as you pivot into executive leadership or super specialized green process design, the financial ceiling in this industry is just phenomenally high. All right, our final section, Part 6, your global career pathway. How to take your skills overseas. One of the absolute greatest benefits of this specific degree is that it acts as a highly demanded global passport. Why? Because the laws of thermodynamics are exactly the same everywhere. This is especially true if you master emerging fields like the green hydrogen economy. This is all about developing sustainable systems for green hydrogen production, using things like water electrolysis to replace fossil fuels completely. If you can master these advanced, self-sustaining energy technologies, I promise you international markets will practically fight to hire you. The overseas opportunities are just incredible. Over in the USA, chemical engineers command an average salary of over $95,000, and there are super clear pathways like the OPT STEM visa for international grads. Germany is another great spot, offering fantastic roles averaging around $53,000, with direct access to the EU Blue Card pathway. Whether your dream is to work in the cutting-edge semiconductor fabs of San Francisco or the advanced polymer labs over in Munich, this degree firmly plants your foot in the international door. So I want to leave you with this final thought. You've seen the incredible demand for green tech. You've seen the rigorous but super rewarding academic roadmap, the financial perks, and those global pathways. This isn't just about mixing a few chemicals in a lab. It's about designing the massive, scalable systems that will literally save our planet and power our future society. So, are you ready to engineer the future? If you are, this is absolutely the academic path to choose. Thank you so much for joining me on this explainer today, and I really hope you feel totally empowered to take that next big step in your educational journey.